Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of an oblique line which is located in first quadrant. So here we can go through the statement. That is point A of the line AB. It is lying 15 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So another point B of the line AB, it is located 30 millimeter above the horizontal plane and 35 millimeter in front of the vertical plane. And the distance between their end projectors as measured parallel to the XY reference line, this happens to be 50 millimeter. So we are required to draw the front view, top view and right hand side view projections of the line on the common reference lines, that is XY and X1, Y1 reference lines over here. And we will be joining the front view projections corresponding to the object line, that is A dash with B dash, A with B and A double dash with B double dash. So to begin with, we are going to start with the construction of the XY reference line. Now we are also going to draw the X1, Y1 reference line corresponding to the profile plane intersection with HP and VP. Now we have to draw the front view projections. So the front view projections and the first angle projections when the object is lying in quadrant number 1 will be drawn above the XY reference line. So the front view of the object will be drawn above the XY reference line. Top view of the object or the line will be drawn below the XY reference line, and the right hand side view projections of the line will be drawn on the left hand side of the front view. So in order to transfer the distances from the top view onto the profile plane, now we have to draw a transfer line at an angle of 45 degree. So you see, we could have drawn an arc over there also, or else we can use a transfer line at an angle of 45 degree in order to be able to transfer the distances from the vertical plane, that is from the top view onto the side view or the profile plane projections over here. So let us start with the location of the point A in the orthographic projections. So we know that point A, it is located at a height of 15 millimeter above the horizontal plane. So we have marked this distance 15 millimeter above the horizontal plane or above the XY reference line. And we must also make sure whatever horizontal distances will be there or locus lines will be there, they will be projected onto the side view, right? So here we have marked the location of the point A. So the moment we mark the location of the point A in the front view, so point A dash will be obtained. So point A dash has been obtained in the front view projections over here. So from the projections of the point, we know that wherever point A dash has been located onto the same vertical line, we are going to get the projection of the point A, that is the top view projection of the point A onto the same vertical projector line. So we know that point A, it lies 20 millimeter in front of the vertical plane. So this distance in front of the vertical plane, it will be drawn below the XY reference line because the horizontal plane has been rotated in the clockwise direction. So point A dash was located over here. Point A has been located in the top view projections. And the moment you see, we locate this point A. So once again, the distance from the vertical plane of 20 millimeter has to be transferred into the side view projections over here. So that is why a horizontal construction line has been constructed so that it should be extended to meet this 45 degree transfer line over here into this particular projection coordinate system. Now having located point A dash and point A in the space, now we know that the distance between the coordinates of point A and point B of this particular line AB, it is equal to 50 millimeter, which is measured parallel to the XY reference line. So please see, this is our XY reference line. So alongside this XY reference line, we need to measure a distance of 50 millimeter from this vertical projector line corresponding to the point A. Now, once I measure this distance of 50 millimeters, so I know that I need to draw a vertical projector line onto which the location of the point B dash will be located above the XY reference line, and the location of the top view of the point B, that is top view, will be located below the XY reference line. How we have decided about that? Because point B also lies in the quadrant number 1. So in the first quadrant, the front view will be located above the XY reference line and the top view will be located below the XY reference line. So for that purpose, we need to know the distances of the line above the horizontal plane and the distances of the line in front of the vertical plane. So we know that point B, it is located in such a way that it lies 30 millimeter above the horizontal plane and 35 millimeter in front of the vertical plane. So point A as well as point B, it lies in quadrant number 1. So that is why we had discussed that this line AB happens to lie in first quadrant. Now we are going to plot this location of the point B in the front view projections over here. So we know that this point B lies 30 millimeter above the horizontal plane. So we are going to mark a distance of 30 millimeter above the XY reference line or above the horizontal plane over here. Now having marked this distance, we can mark the location of the point B dash in the front view projection. So we have obtained A dash, we have obtained the point B dash corresponding to the end B of the line. Now we can join points A dash and B dash. So we will be able to obtain the front view apparent length of the line above the XY reference line over here. And the moment we obtain point B dash, so once again, we have to draw a horizontal locus line corresponding to this point B dash so that point B double dash in the side view could be located onto the profile plane. Now, having located front view corresponding to the point B, that is point B dash, now we will proceed with the evaluation of the top view projection of the point B. So we know that the distance of the point B from the vertical plane happens to be 35 millimeter. So now we are going to mark this distance of 35 millimeter below the XY reference line. So the point B coordinate in the top view will be located. So point A had already been located. Point B in the top view has been located. Now we can join points A and B in the top view orthographic projections, which will provide us with the apparent length top view projections in the orthographic view over here. So having obtained this point B in the top view, so once again we have to transfer this into the profile plane. So the distance of this point B from the vertical plane, it happens to be 35 millimeter. So this distance of 35 millimeter from the vertical plane has to be transferred onto the profile plane projection, that is side view projections over here. So for that, we are going to draw a horizontal construction line originating from the point B such that this horizontal projection line will be extended up to the transfer line which we had already drawn earlier, and once this horizontal construction line intersects with this transfer line over here, now from point A coordinate and from point B coordinate over here which is available onto the transfer line two vertical projector lines now we are going to draw over here, which will be extending upwards, and they will be extended up to the coordinate location of the horizontal construction line which are emerging from A dash, and another construction line we are going to draw from the coordinate location of the point B, and it will be extended up to the horizontal construction line which is emerging from the point B dash in the front view. So please check, this point location will be B double dash, this point of intersection will be point A double dash. So once again we can check, here we have got the top view construction corresponding to the point A. So this distance we have transferred onto the transfer line and project this point A into the profile view projection and extend this vertical projector line up to the horizontal construction line which is emerging from the point A dash. Wherever these two construction lines they intersect, we are going to obtain the location of the point A double dash. Similarly, in order to obtain point B double dash, first of all, the height will remain same in the side view as well. So this construction line will be extended horizontally from B dash, and we have to keep on extending this till this horizontal line it intersects with this vertical projector line which has been drawn as a result of this distance of the point B from the vertical plane. This happens to be 35 millimeter. So this distance has to be transferred from the top view projections into the side view projection. So once we reach this point, that is this horizontal construction line, it intersects with the transfer line. Now a vertical projector will be drawn through this point B, and wherever this point B vertical projector line it intersects with the horizontal construction line which we had drawn earlier through the point B dash. So this intersection of these two construction lines will provide us with the location of the point B double dash. So having obtained A double dash and B double dash in the profile plane, so we can join A double dash with B double dash, and this will provide us with the right hand side view projection of the line AB in the orthographic projection. So we can see over here that this is an AB line which is oblique in nature. It happens to be inclined to both the reference planes HP and VP. So A dash B dash, it is also inclined to XY reference line. The top view projection AB, it is also inclined to the XY reference line, and by using the data available from the front view and the top view and transferring the top view distances using this transfer line into the profile view, we have been able to obtain the locations of A double dash and B double dash. So this way we have been able to obtain the orthographic projections of an oblique line AB. Since all the projections they are inclined, so we are not able to get the true length projections of this oblique line AB into the orthographic projection. So this is all for today. I hope that through this discussion you would have understood about the procedure, how you can make use of the information available with you regarding the coordinates of the points A and B to evolve the orthographic projections of the line, that is front view, top view and the right hand side view projections of this line in the orthographic projection system. So we'll be continuing with further discussion regarding few more cases of the projections of the lines in the coming lectures. So thank you very much. Thanks a lot.